we have done a lot of review now, and we have discussed a lot of points. So I will stop for a while so we can go to questions, we can try these concepts, then we go to next concept. So I will explain you some more points. So you can see here now. So try this question now, read question carefully and try to answer. So try to figure out your own answer. Okay, so this is for uniform electric field. Total work done is asking you total work done. So another way to say this one is you need to calculate the electrical potential energy. So another way. So formula for this one we have Q times delta V. So you need to figure out how much is the charge here and what is the potential difference. So potential difference, if I move from here to here, so the potential difference between these 2 points. So you have to be clear about points. So we have 2 points here. So the potential difference between 2 points is 40 volt. So you can just multiply and you will get your answer. And the amount of Q is given to you, this charge. So this is just to confuse you. Don't worry about that one. Formula is quite straightforward. Q times delta V. Okay, if delta V is 0, for example, if I move my charge, for example, from here to this point, how much work do I need to do? If I move charge from here to here, okay, excellent. I think answer is this one. Excellent. So now you see, if I move charge from here, let's say this is point A to point B, work done has to be 0 because along this line there is no potential difference. So it doesn't matter I go like this, it doesn't matter I go like this. Okay, excellent, it has to be 0. Excellent. So it doesn't matter I go like this, any path I follow, if I go even like this, then come to this one, the work done will be the same because delta V is the same and Q is the same. So the answer will be this one, just multiply. So you have 40 and we have to multiply with this one. If I move charge from here to here, then you have to multiply by 20. So just you need to understand delta V between 2 points and then you can figure out work done. So this is how we can answer. I hope most of you are clear about this one. So let's move on to next now. So the answer should be E for this one. Excellent. So now let's try this question now. So take some time and try to answer. So the formula you will need for this question is, maybe some student didn't remember formulae, so I will just write down formula for you to help you a little bit. So yeah. Okay, excellent. If you have got answer, I'm not clear if it is answer. It should be greater than 0.36. So this is not, you see here, this one you need to understand. Sometime in exam, we need to understand how to figure out answer quickly. So this one, if distance is this one, or if distance is this one, the force is this. Now, if the distance is shorter, force has to be greater. So it means this is not possible, this is not possible, and this is also not possible. So the answer is here between these two. So how we can figure out? So the best way to answer this one is, if you look at this formula, so this is one way we can cancel it is not possible, not possible. Then we can find out. Even sometime in exam, if you have short time, you can just look and you can answer without calculations. So, but if we do calculations, we can do like this. Now, we need to understand in this formula, for example, we need to understand two positive charges. So it means the next situation is like this. So the next situation is like this. So we have this distance. So let me just explain this one. So this distance is given to you. You see the charges are the same. This is Q1. This is also Q2. is the same. This is also Q1 and this is Q2. Same charge. So in this formula, we need to find out what is same. So I will simply say this stuff is same. So I no need to worry about this one. So I will write down the formula that F1 D1 square is equal to constant. Okay, you see, it's so simple now. So now we will say that F1 D1 square, for example, it also true for the other one, means it has to be equal to F2 D2 square. Now what we need to find? We need to find F2. So simply F2 is equal to F1. F1 was given to you. So I will just write down the formula, then you can plug in values by yourself. So and you will get your answer. So F1 is here. F1 D1 square. So just plug in divided by D2 square. So the F1 you see is given, D1 is given. Just plug in and you will get your answer. So this will be the answer actually. So this is how we can answer. You can simplify and you can find the answer. Okay, so I hope this is clear to you. So if this is clear, we can move on to next one. So then you can find your answer. Okay, so let me check answer now. So answer is A. So this is by ratio we can find out. Okay, let's try this one now. I think you don't need calculation for this question, but it's conceptual question. So read this and try to answer. So read question carefully. Okay, let me highlight some points for you. First thing is net negative charge is given and charge is at rest. So which statement is true? So simply the best way is that okay, excellent. So here please, this is how you can draw. This is your negative charge now. So this is at rest now. So it means excellent. Answer is C. But this is straightforward question. So this is how you can answer. Now you see it's directed into the rod. So this is directed into the rod. So this is how we can answer. Okay, excellent. If you got right answer, wonderful. So let's move on to next. So the answer should be C. So let's check answer here. Okay, this is then simply is asking you about electric field, direction of electric field. So these electric field lines are telling you is that if you place a positive charge here, the force on this one will be to the negative charge, that's all, or into the rod in this case, in this specific questions. Okay, so let's try next one now. Okay, so please read question and try to answer first by yourself. Okay, so you just need these formulae actually. This is conceptual question. I just write down these formula for you to just recap and understand this. Okay, so if you look back actually, as I explained to you previous actually, if you have one sphere and you have another big sphere, if we connect them together, let's say this one has, okay, it has to be excellent, it has to be E actually. If we connect them, let's say this has a Q charge, so this charge will start, if this has zero charge at the beginning, when it was not connected, but when you will connect this one, this charge will start flowing from here to here until this V1 is equal to this V2. If this is 2, for example, if this is 1, so charge will flow until V1 is equal to V2, until there is a potential difference. So this is same potential means delta V is 0. So this is simply telling you delta V is equal to 0. So this is important, you need to understand. So that's the reason we apply a battery. For example, when we have a battery, we see current will start flowing. If no battery, no charge will flow, means there is no net flow of charges. So there must be a potential difference. Otherwise charge will not flow. Okay, so Okay, so this is the answer. Okay, let's try this one now. Okay, here please, now for this one you need to understand midway between two charges plus 3q and minus q are separated by a distance 2d. If the Coulomb's constant, so we have two charges, you can see here we have these two charges placed here, so you can say here, and is placed midway, so here you can find out, so this distance is equal to 2d, this distance will be d, and this distance also will be equal to d. Okay, so just 1 minute. So in this case, for example, you need to understand is that if this is a positive charge, so the force due to this one will be this way. So this is force due to plus 3q will be this way. It will apply force this way. But this is a negative charge. So for negative charge, also we understand this will also apply force this way. So the force due to minus negative also will be this way. So now what you need to do is the total force on this one will be equal to force due to this plus force to this. So then you can calculate. So this will be k times 3q over. So this is the force. So don't worry about negative signs now, because direction is same, so the force is in the same direction. So then you can multiply. So this is d square, here you have a q, and plus total force, this will be k, and you have q, this is q over d square, and you can add and you will get your answer. Okay, so this is how you can figure out this now. Simply this is the thing you need to understand. You have to add the force because the force is in the same direction. So this is what we need to understand. Okay, so this is our answer. So if you add, you will get your answer. Okay, this is how we can figure out. Okay, so here. Okay, so try to answer this one now. Okay, so in this case, we are no need to worry about direction actually. So let's say this is negative plate. I place this minus 24 millicoulomb here now. Okay, E, excellent. So the work done simply is equal to Q times delta V. Q times delta V. Now delta V is not given to us, so we can little bit modify this formula. So we understand that E is equal to delta V over D. So delta V is equal to E times D. So we can say this is Q E D. So now you can see here the Q is here, this is given to you, and D is given here, and E is given here. So we just need to multiply. If you multiply, you will get your answer. Okay, just multiply. If you you will get this answer. That's right. This you see here. Sometimes I no need to do calculation. I can look at these numbers. So these are not possible. These are very small numbers. So this is okay. So in exam, you need to look at this one like that. Then you can find the answer. No, if you start calculating, maybe it will consume a lot of time. So this is one way you can quickly figure out. Okay, so this is our answer. Okay, now different type of question for you. So try to answer this one. This is conceptual question. You don't need any calculations. Okay, so what is our answer? Answer is not only B. Is asking you region 2 has the same. This one you see region 2. Okay, so it you can. Okay, excellent. Okay, this one please. The question is asking you. Let me explain to you question now. One student has got, I think, right answer. So let me explain to you question now. Little bit explain question, and then I will show you the answer and answer. First of all, let me explain you question. So the question is asking you is that if you have a charged rod, this rod, I just draw positive actually. It can be positive, it can be negative, it doesn't matter. So I just draw positive. If this rod is positive and this is a conducting sphere, means a metal, so it means that electrons can move easily inside this one. So when you bring a positive charge, so this side become more negative because this will attract negative. So more electron will stay on this side, or simply we can call that, say that this side will be more negative. So the opposite will be more positive. So the same is true for this one. It also have no net charge at the beginning. So the more charge electrons will stay on this side. So this side will be more negative. So you see, this is more negative, this is more negative. So this is one thing we understand. Now the question was asking you, region 2 has the same polarity as region. Same polarity means that if it is negatively charged, so which side is negatively charged? If this is positively charged, which side is positively charged? This is what question is asking you. So we use positive charge here, so this will be negative. So which side of this one is negative? So this is negative. So the answer should be B for this one. Okay, now if we bring negative, result will be the same. So if let's say this is negative now, so let's say this become we have negative rod now, because it was not given to you the rod is positive, rod is negative. So because question is based on that. Now let's say if this rod is negative now, so electron, they will repel electron from here. So more electron, they will leave this side. So they will sit away from electron. So this side will be more positive. So this is more positive. Same will happen here. So this side will be more positive. So electron will stay here. Now if this is positive, which other region has also net positive charge? So this has net positive. So this is what question was asking you. The same polarity means the same net charge as here. So on this side, this is net charge. This side is also. So they are the same. So it means it has to be B. So is this clear now? Okay, so is this one is clear? So we can move on to next one if this is clear now. Is asking same polarity means net charge, the same net charge. Here, same here. Okay, so now I will go to next topic now. There are a few more questions, but there are a lot of questions given in topic wise questions. So you can practice from there. Now let's move on to next topic. Okay, in notes, these are given to you. So you can do more question about this topic. Now let me explain to you the next topic. So I will move on to next topic now. So is this is clear? Okay, so the answer is B. Okay, so these questions these are given in your notes actually, so you can practice from there. So let's go to capacitance now. So capacitance is a new topic we need to understand. Okay, so for capacitance. Okay, here please. First of all, for capacitor, there are few things you have to be very clear about that. If we have two plates, let's say we have these two plates and we have one switch here, and let's say we have also one resistor here. I attach one resistor and now we connect this one with a battery. So you can see here, if we connect with a battery now, if we connect with a battery, now what will happen is that as soon as we close this switch, so the electrons from this plate, first of all, you need to understand the basic thing you need to understand is that if I have two plates actually, there is no net charge on these two plates. There is no net charge. So when no net charge, when we talk about this one, no net charge, it simply means that it has same number of protons, same number of electrons, so there is no net charge on this one. As soon as we close this one, so this side means electron will leave this plate and they will be attracted towards positive terminal, and from here negative electrons means the charge will go on this plate. So with time what we will see is that this plate become more positive, it is connected with positive plate, and this side become more negative. So what we did in this case, actually, if you look at the big picture of this one, what happened in this case is that only charge separation. What we did is that we just separated charge. So this is only charge separation. Battery is not giving more electrons, or there is no any net charge. Plus Q you have here, you have minus Q here. The amount of charge on this one is equal to amount of charge here. So what happened is that in this case we store energy. So the capacitor is used to store energy. So in this case what we did, by separating charges, we have stored energy on these plates in electric field. So this is what happens. So this is R. So at the beginning, at t is equal to 0, when the t is equal to 0, or you just close the switch. Just close a switch closed. I will simply say when you just close switch, when switch closed at the beginning, when you just close this switch, what will happen is that charge will start flowing actually. So at this point, if you need to calculate I, what is value of I? So let's say this battery is voltage is V. So I you will calculate at the beginning, that will be equal to V over R, as you will say there is a no any capacitor here. So we will simply say when it is not charged, when capacitor is not charged, so it is just acting as a wire. Simply I will say that it is just acting like a wire. But as it will more and more charge will be stored on this one, so finally it will stop. There will be no current. So how we can understand that one? What it means is that, let's say this is voltage of the battery, and let's say the voltage across these plates, let's say, is equal to Vc. C means the voltage of capacitor. At any time, VB has to be equal to Vc plus VR. Okay, Vc plus VR. So with time, as the time is passing actually, as the time is passing, what is happening is that this is not changing. Voltage of the battery is not changing, but the voltage of this resistor will go down and voltage of the capacitor will go up. And finally, what we will have this will be VB and this will be equal to Vc when capacitor is fully charged. So when capacitor is fully charged, I will simply say when capacitor is fully charged, at that time VB will be equal to Vc, means the EMF of the battery will be equal to voltage across these two plates. So we will say VR will decrease, Vc will increase. If you calculate at time t is equal to 0, of course this doesn't make any sense, but t0 means that when you just close the switch, just switch is closed. If you look at this point, just switch is closed. If we look at that point, so we will simply say at that moment VB is equal to Vc again and is equal to VR. But at that moment, this will be 0. And at that point, VB will be equal to VR. Okay, so this will be true. Later I will also show you the animation actually. Let me explain you a little bit. Then I will go to animation. I will explain you from animation. So first I want you to have a little bit understanding of this. Now this is how we can calculate. Now the next thing we need to understand is that we have studied about resistors in series and resistors in parallel. So how about capacitors in series? For example, when you connect capacitors in series, so here I will write down when we connect capacitors in series, and here I will write down when we connect capacitors in parallel. So we need to understand, because we will discuss later RC circuit. RC circuit means resistors and capacitors. They are in the same circuit, as you can see here. This is an example of RC circuit. Means you have a resistor and you have a capacitor in the same circuit. So RC circuit we will discuss in detail. Maybe not today, we don't have enough time, but next class I will explain. So capacitors in series and capacitors in parallel. So if we have this power supply here, and we have, let's say, one capacitor here, and I'm not drawing any resistor here to make it simple. So, and we have another capacitor here. So let's say this capacitor is C1 and this capacitor is C2. So I'm just talking about capacitors only here. So how about the total capacitance? So how we calculate? So if this side of the battery, it is positive, this is a positive terminal of the battery. So you will simply say that, if this is positive, as I explained to you here, this side also be positive, because electrons will move from here to positive terminal. So electron will move from here, lack of electron. So here, so this side here will be positive, because this will go, electron go from here. Now then electron will stay here. Now if this side is positive, how about this one? This you will simply say it has to be negative. And these electrons will come from this one, because when these electrons will come, electrons from this plate will be repelled and these electrons will stay on C1. So this will be positive. This will be positive. Now you can see from here is that in this case Q is the same. Q on C1 will be equal to Q on C2, because this charge is just induced. When electrons come here, they repel electron from here. If you want to see little more clear, I can say here at the beginning there were electron here. As these electrons came, they repel these electrons, so they move to next place. So now here are no electron, it means here. So these electrons move to next one. So here now what we have only positive, net positive charge. There are electrons, but we are saying net positive charge. So the Q is the same. Means the Q on C1 is equal to Q on C2. Other way you can also say Q1 in this case is equal to Q2. Okay, now if this is voltage V, so this voltage has to be V1 and this one has to be V2. So we will say V of the battery means the potential difference across battery, or you can say EMF of the battery. This is ideal battery, it has no internal resistance, so the V has to be equal to V1 plus V2. Now how we calculate capacitance, the relationship between Q. Now we need to understand what is relation between Q, V and C. So that relationship is, we can calculate Q is equal to CV. Here please. So Q is equal to CV. Now the V, for example, here we have. Now if we need to calculate C, so we can rearrange this formula and we can calculate. So we can replace these two capacitors with one capacitor. So we can replace with one capacitor. So we can write down the C from here. This will be equal to Q over V. So the C will be equal to Q over V. So the C is equal to Q over V. So if we rearrange from here, so from this formula we can rearrange and then we can calculate. So now V, for example, here, so V is equal to, if you want to write down V, so V will be equal to Q over C. So I can replace this one with Q over C. This is the total capacitance, and here you can find this is Q1 over C1, and this will be equal to Q2 over C2. So you will get 1 over C is equal to 1 over C1 plus 1 over C2. So this is a formula. This is just similar to resistors in parallel. So here is just opposite. So 1 over C means the C equivalent is equal to 1 over C1 plus 1 over C2. And if we repeat the same process for capacitors in parallel, so we can have two capacitors like this. They are connected in parallel, so we can also derive the formula. For this one I will just write down the formula. I will just explain a little bit and then I will just write the exact formula, final one. So let's say this is C1, its capacitance, this capacitance is C2, and let's say this voltage is V. Now in this case, imagine this one. Look at this. These are two capacitors now. We connect them like this here. You see, if I bring them together, I can connect them like this. This become one big capacitor. Simply, you have two capacitors, they are in parallel, you combine them. So you get one big capacitor here. So what it means is that if we look at this one, so simply this one is telling us that the V in this case has to be the same. So see, voltage across this one has to be the same as this, So V is equal to V1, and this also has to be equal to V2. So we can rearrange formula. Q is equal to CV, and we will get actually in that case. In this case, you will say that Q has to be equal to Q1 plus Q2, the charge. Simply if you rearrange, you will get C is equal to C1 and plus C2. Okay, so this is what we will get. This is just opposite to resistors actually. So this is just opposite to resistors. When resistors are in series, it means capacitors are like in parallel. So this is also true when the capacitors are in parallel is similar to resistors are in series. So this is how you can remember this one. Okay, so this is how you can remember. Now, one last thing, then we will stop over class. For example, if we have two capacitors, for example, let's say we have two capacitors. So here, let's say we have two capacitors. We connect them first of all in series. Just last thing, then class will be over. Just let me explain one thing. I just want to talk about energy store on capacitor. Let's say we have here, let's say this is equal to 12 volt battery, and we have one capacitor here. Let's say this is 3 microfarad, and this one okay, let me just use the big number for simplicity. This is 3, and let's say this one is equal to C2, this is equal to 6. This is equal to 6 farad. It's a big number, but just for sake of calculations, I'm just going to make it simple. Here, now we have another setup here. Let's say we have two capacitors. These are two capacitors here. So this is battery, and we can attach other capacitors here. So we have C1 and we have C2. Let's say this is also 12 volt, and this one again I will say this is equal to 3 farad. Farad is a unit of capacitance, so the unit of capacitance farad. So unit of capacitance for a student who didn't study this one, so you need to understand the unit of capacitance is farad. Farad, and we use capital F for this one. So this is equal to 6 farad. Now, which capacitor will store more energy? So first thing you need to, okay, so which one? So which setup will store more energy? Is it in series or is it in parallel? So which one will store more energy? Is it when you connect your capacitors in series or when you connect your capacitors in parallel? So you have two options. So one is series. If you want more energy to be stored on your capacitors, how you will connect them? It has to be in series or it has to be in parallel. So now you will answer this question without calculations, but next class we will do calculations. Okay, so you can just answer this one based on capacitance. Excellent. So you can answer simply this one now based on capacitance. If they are, in this case for example, what is the C equivalent? Total capacitance. So if you multiply these two, so and divide by sum of them, I think you will get 2 farad. So this is the capacitance. And if you, this one here, if we calculate, so in this case, we will get the C total will be equal to 9 farad. So this is 9 farad. Okay, so more capacitance, same voltage. So it means that if this formula, you see the beauty of this formula. So this is telling you Q is equal to CV. If this one is the same and C we increase, it means that capacitor will store more energy if V is the same. So this one will store more energy. So if we want to connect capacitors in a way we want them to store more energy, we need to connect in parallel. So next class we will do calculations and also do more questions about RC circuit, and then we will move to magnetism. Okay, so that's all for today, and I hope now you have studied a little bit more about electricity. Okay, so that's all for this class, and see you on next Monday.